Okay, so guys, we're about to get going with our exam workshop. And if I look at the poll, it's very, very helpful for me to see this. I think the majority of students have spent some time looking at it, but most students would like fairly detailed help going through the questions. And so just want to, did I lose someone there? Lebo, if I could just ask you to take screenshot. Can you see the poll? If you could just take a screenshot, maybe on your side of the poll. Okay. So let's get going. So basically what I can see, guys, is most of you have had some look at it. And some of you will even spend quite a lot of time on it, but most students would like quite a lot of help going through most steps in detail. Okay, which is what the baseline of what we're going to do. And then we will alter it if it changes in later questions. Okay, so let's get going with the workshop. So I've set many grade 11 papers, and almost every single grade 11 paper 1 starts your exam with an algebra question. And what I want to do today is I just want us to start by trying to solve these two questions. Now, some of us will get stuck, but I just want to give you 3 minutes to try and do as best you can on these two questions. The key word is to solve for X. Once you've had a chance to go at them, I'm then going to talk about some important theory that I need to make sure everybody knows about. But I think it's important we all just take 3 minutes. And if you're able to get the answer, put that answer in the chat. If not, then in 2 or 3 minutes, we'll start going with this. Okay, over to you guys. Just going to give myself a little bit more space. Okay. All right, so the questions in yellow are what's getting our attention. And what is really nice is if you get these questions, right, it really helps your confidence going into the exam. And so I think it's important that we, to see how you do. Yeah, keep those answers. Once you feel comfortable putting an answer in the chat, please do that. We've still got another minute and a half or so. Okay, have we hit the mute all button yet? Have we, or I can't remember.
I'll check it now.
Because what I'm gonna ask students to put their hands up, but it's going to work better if we hit the mute all button. So if you could just hit that now.
Mr. S, please unmute yourself.
Yes, I best unmute myself. Okay, guys, what I would really like, we're not quite there yet in terms of having enough time, but if anybody, actually, let me give you another 30 seconds or so, and then I'm going to ask for some feedback about how we would get the answers to these. Okay, so remember if you're solving an equation, there may be some basic steps that you always need to follow, and you may even need some tools that you need to use. And so I want you to think about what those tools are. Okay, so if anybody, I would love to hear from someone who solved 1.1. I want to know what is the key step that you found helped you to solve this question, because we're going to solve it now. And I want to know if anybody's willing to share what helped them. So maybe Seth or Wakihe, what was the key step that helped you recognize how to do this question? Because you have got the correct answers. And I'd love for you to share some of your knowledge with the fellow students. If you put your hand up, then I will unmute you. Otherwise, I'm going to explain both questions now. It's always nice to hear from a student if the students are willing. Is anybody? Okay, Younger. So let's ask Younger to unmute. What did you find was the key step, Younger, to do this question?
So I first put the question in standard form, then I
very important.
Then I factorized it.
Okay, so this is really, really important. It was moving the 12 across that put it in standard form. Thank you, Younger. That is super helpful. So whenever we are solving an equation, it's really helpful to put it in standard form. Now, this is a particular type of equation. This is what's called a quadratic equation. And we know it's a quadratic because of the x squared. Now, there's two choices here. Some people will choose to factorize this and get something like that. Others will use the formula. Okay, so there's two choices, two ways of doing this. I think the most reliable method is probably the formula, but you need to actually do both. So let me, for now, do both. So when I'm factorizing my trinomial, I'm using this method. Let's see, 4 and 3. And so that doesn't quite, let's have a look. What do we need to get? Take a moment. So we need to get to -5, and 4 and 3 would get us there. So we get -8 plus, and so we should get 2x plus 3 and x minus 4. Okay, so I factorized my trinomial, and now I know that if either of these two brackets is equal to 0, that will be an answer. So we can say like that. And then if we solve this equation down here, we get 2x is -3, and then x would be -3/2, or x would be 4. Now, that's the one set of answers that we can get. If we had used the formula down here, what we need to recognize is what thing is a, and a is going to be 2. And in this case, b is going to be -5, and then c would be the -12 over here. So a, b, and c. And so if we did it with the formula would be -5 plus minus whatever that is. So 2a. Now we know that a was 2 to start with. And if we went with b squared would be that. and then we would times it by 2, and then we times it by minus 12. Now, just for bonus points, because we're going to do this later in the lesson, what is this thing inside the square root bracket called? What is that thing called? You can put it in the chat if you like. So I think this thing is called delta, and in this case, it's going to be 121. Let me just zoom out for a second. So if I was solving this using the quadratic formula, I would basically just go x is equal to 5 plus the square root of 121, which is 11 over 4. Or x would be equal to 5 minus 11 over 4. And that would give me the same answer because 16 over 4 is 4. And this one would give me minus 3 over 2. Now, the reason I bring up delta, guys, is later in the lesson, I'm going to talk to you about something called nature of the roots. And in nature of the roots, you need to find what delta is. And I want to point out at its early stage that delta is just this thing inside the quadratic formula, which is over here. Okay, now the second one, I'm going to go a little bit quicker. I'm going to use the same tip that was given to me by a student earlier on and say I need to get this into standard form. And so I'm going to take the question and multiply out my minus 4x, and I get minus 4x squared. Then I'm going to get plus 8x equals minus 7. Okay, so now I've got that step. Who would like to tell me what I need to do to get this into standard form? And also, I'd be interested to know, would you use factorization or would you use the formula? I'd love it for a student to help me, maybe who's got this right, because 1.2 is worth 4 marks. It's a little bit trickier. I think I've multiplied my brackets out correctly, but I would love to know if somebody would give us some guidance as to what we need to do next. If you're willing, just raise your hand and then we can hear from you. Okay, otherwise I will go ahead and explain, but I just want to. Okay, Nolwazi, yes. Nolwazi, what do you think is important to do now at this stage?
I think that first I would change the sign of negative 4x squared.
Okay, how would you do that?
Divide everything by negative 1.
Okay, and if we divided everything by negative 1, it would change to 4x squared minus 8x equals 7. So that's what you would do, huh?
Yes, and then take the 7 to the other side, and then it will become 4x squared minus 8x minus 7.
Cool. So what I'm going to do, well, you're absolutely correct. What I just want to suggest is some students might find dividing by negative 1 a bit tricky. So you're completely correct, and you'll see we get the same answer. But what you could also do is you could move the 4x squared to the other side. And if you had that, you get 4x squared, a positive 4x squared on that side. And I'm also going to move this 8x. And that's going to become minus 8x. And now I've got my standard form in the same way that we would have got the same answer as you. And so then the final part to get my answer, Nolwazi, did you use your, how did you solve this last part? Sorry, I think you may have left. Can you come back and tell us, how did you get from that point to the final answer there?
I factorized everything. I just factorized.
All right. Can I make the recommendation, Nolwazi, that sometimes the quadratic formula might be more reliable? It's not that factorizing is wrong. It's just that given a choice, the formula is always going to work, whereas often students will have to do the sort of balancing method with crosses and stuff, whereas if we go straight to the quadratic formula, all we need to make sure we've got is our a value. So in this case is a, B is -8 and C is -7. And what I want to say to you is start by leaving like a little space. So minus B so we know that to solve this, all I need to do is fill in those spaces. And so what am I going to fill in what space with? Well, this is a -4. And then this one over here, the squared is a B, so that's going to be a -8. This is a -4. Oh, this was C, so that's -7. And then this one over here should be -B, so it's a -8. And then we can clean things up a little bit, because minus a minus is a plus. And this, guys, this is where I would use my calculator. So it's a little bit confusing. And I think you want to compute the step all at once. And so we go -4 times 7. And what do we get there? 64. Have I made a mistake here, guys? Let's have a look here. -4x squared plus 8x is a, here we go. I've made a mistake. There's no -4 over here. There should be a, so have a look. And that's how easy little mistakes can creep in. What we notice is that this should be a 4 because there's a 4 at the bottom here. And then let me check my other bits. The -8 I'm happy with, the -7 I'm happy with. And so what we should get is 64. So -4 times 4 times -7. Did you guys get 176 over -8 over there? Let's just move this out the way. And so then my final answer is going to be 8 plus the square root of 176 over -8, or x is going to be 8 minus the square root of 176 over -8. And you should get minus 2.66 on that side. And then on this side, you should get x is minus 0.66. Okay. Okay, let's have a look here.
Mr.
Yeah.
Sorry, can you please explain the minus at the bottom? Why it's a -4 in the bracket?
Okay.
In the first step.
So I have removed, let me just remove some stuff for a second, just so we get this out the way. So we should have, if we went back to the very beginning, we have this thing like this, and we get -4x squared plus 8x equals -7. And then I moved things across, and I got 4x squared minus 8x minus 7. Okay, I see what you mean. So now, if we have that, let's have a look. So are you happy that my b is -8? So that should be a -8, and that should be a -8. Oh, this should be a -7. I see what you mean. So that comes from there. And what you guys are saying is that this should be a 4. So you're quite correct. There's a little mistake there. So that should be a 4. And so this should be an 8. You're quite correct. And so the answer should then be a positive. Well done, guys. Just shows you how little mistakes can creep in. Positive 2.66. And then negative, this should also be a positive 8. And we get minus 0.66. Okay, yeah, Bonga, I'll unmute you there.
Hi, sir.
How's it going?
I'm on you.
Good, good.
I wanted to ask, instead of bringing the negative 4x squared and the 8 to the other side of the equal sign, is it okay if we bring the 7 to the other side? I mean, the negative 7.
The negative 7. So you're talking about this part over here. So can you
yes.
bring it across? Yeah, you could, and you should get the same answer. So you're just basically, yeah, you absolutely could. Yeah, no problem with that. Okay, so what I wanted to do next is just want to get a sense, thumbs up if you feel like you're comfortable with that, thumbs down if you feel a little bit rushed by all the stuff that was going on. Now I'm going to clear my board. Go ahead, Teddy, raise your hand and we can have a little discussion while I clear my board for the second part of the lesson. Okay. So the guys, the other thing is the reason I'm using the quadratic formula, it may be, is it's just very reliable, but it sometimes does take a bit of practice to get used to it. Okay. Now, the second question, the second one I want to point out is, before we even start this question, I would love for someone to suggest to me what's your strategy for solving 1.3? And then I'm going to let you try and do 1.3 by yourself. So who has a strategy for 1.3? If you raise your hand, I'll unmute you. I just want a sense of kind of what strategies would you use to solve 1.3? Okay, so Nizole has said LCD. Would anybody like to clarify what LCD means? So I would say that the big problem in 1.3 is that you have these fractions and we need a way to get rid of the fractions. And so we're going to make what's called the lowest common denominator, or sometimes it's called LCM. And for this question, that is going to be x plus 1, x minus 1. So in order to solve 1.3, we're going to try and multiply both sides by x plus 1 times x minus 1. I would like you to try now. If you get stuck, I would invite you to raise your hand and we can have a conversation. But I want to give you the chance to try and do this with the hint that you have to multiply both sides by this thing called the LCM. The hope is that it gets rid of the fractions that are making life so difficult. All right, over to you guys. Just gonna get some water quickly. Aha, good question. So Susanna is asking, are there restrictions? So yes, Susanna, the final answer cannot be equal to -1, or it cannot be equal to 1. But that's like sort of a little thing we'll add at the end. Basically, those answers would cause division by 0. So those restrictions are in play, but we'll worry more about them at the end. Okay. So I want to suggest that both sides of this equation get multiplied by this x plus 1, x minus 1. However, if that happens, what is that going to look like? It's going to look something like, I'll put the stuff in black to start with, the original. So that's, in my brain, if I multiply both sides, or I multiply everything by x plus 1, x minus 1, that's what I'm starting with.
Mr. S?
Yes. Is there
There's
a question?
from Cameron. He's asking if we only multiply the numerator with the LCD.
Okay, so yes. So when you multiply by your LCD, it's actually artificially always over 1. And what that means, the numerator, in case you don't know, the numerator is this thing at the top. And so in some ways, it's interacting with this thing at the top. However, the whole point of a LCD is to wipe out the fraction. And so what we would say is that x plus 1 over x plus 1 is going to be the same as 1. And so it doesn't matter. Well, not doesn't matter. I mean, basically, they're equivalent. It makes it go away. So what I'm interested is, can you guys get to the promised land of the line without fractions? So maybe you guys could even just, in the chat, what do you get as at the step where you're without fractions? Because this is the tricky bit. It's making you out, recognizing that there's a fraction, and so you need to multiply through by this LCD. Doing it is the blue step. Notice how I'm multiplying everything by that LCD, and now it's the cleanup phase.
Mr.
Abigail.
S, we have a question from Abigail.
Yeah, go ahead, Abigail.
Hi, sir. So, after we cancel out at the second step, like after we did it over everything,
Yeah.
and then by the second step, do we use like the distribution law, and that whatever law needs to be applied to put it back in?
So what I'm going to say, Abigail, is step 1 is to deal with the issue of a fraction. And in order to deal with issue of the fraction, you need this LCD. Or LCM, it's often called in textbooks. Here, the lowest common multiple of the denominators. Now, this next step, I call the step 2, is doing this. And then step 3 is the cleanup. And so what has to happen is these two cancel each other out. And what is left behind, you're talking about this interaction here. The good news is x minus 1 times 1 is just going to be x minus 1. But the second bit is a bit more tricky, because this is going to have x plus 1 times by 2x. And then the last one is going to have x plus 1, x minus 1, because essentially I'm just multiplying everything by 1. And so now I want to see, guys, if we've got through that step, can you use what we've been doing earlier in the lesson to solve this quadratic equation? Or maybe it's not even a quadratic. Well, it is a quadratic, but see if you can solve that. So I think that's applying the distribution law, the 2x goes to that. So that gets done. And then for this one, this is going to happen. Okay, yeah. Abigail, well, can we, let's hear what another question.
Yes, so I made a mistake at the first part, because I said 1 over x plus 1, and then I used the lowest, the LCD, which is x plus 1 and x minus 1, and then I put the 1 over the whole thing of both the brackets. I put the 1, and then I did the same with the 2x, and then it cancelled out, and then I was like 2x and x plus 1.
Okay. Can I suggest that you have a look at after this lesson, there's going to be a memo, and to just look very carefully at that memo as to how that process went down. Lots of students will make silly mistakes in this step, but what we need to remember is that you still get partial credits for the parts that you do right. So even if you made a silly mistake, as long as you haven't simplified the question, you will be able to get more marks if you keep on doing the correct stuff here. So what does that correct step look like? Well, I think my thing to do is to move everything to one side. Oh, why does the LCD fall away? Okay. What happens is when you multiply everything by the LCD. There's a cancelling out that happens. Can you see how over here, the x plus 1 on the top and the x plus 1 on the bottom, they're equivalent to 1. And so because they're equivalent to 1, we don't need to do anything more with them. Essentially, we ignore them, and what's left behind is the x minus 1. Same thing here. It falls away because x minus 1 over x minus 1 is the same as 1. And so that's why in the next line, you just see x plus 1 and 2x. So this multiplying step is designed to get rid of the fractions. And I know students, I'll give you another chance to practice this later in the lesson, but I know it's something you need to practice a lot. Okay, let's do this last bit here. Let's see what we can round up. We've got let's do the 2x squared minus x squared is that part. Then I think that some of the stuff over here, minus x and plus x are the same as 0. So we don't need to do anything there. We do know that x and 2x is 3x. And then what's going to happen is when this minus 1 comes to the other side, it's going to be minus 1 plus 1. So there was already a minus 1 here. I get that. And so then the next step is going to be to say, look, actually, this is x squared plus 3x equals 0. Yeah. So Abigail, is step 3 necessary? Because I see I jumped to that one beneath. No. Yeah. So sometimes you can leave out some of the steps as long as you're getting the same as me. Okay. Then the last thing is going to be to say, can I factorize this? Now you could use the quadratic formula, but in this case, the factorizing is a lot easier. And so you're going to get basically x must be equal to 0 or x plus 3 is 0. And so my two answers should be 0 or minus 3. Yeah, Younger, you want to ask your question? Yeah.
So from the part after we cancelling out, after we distribute, the next step, I think step number 3. How did we get to those values? Because I'm confused on how we.
Which row? What does the row start with that you're asking a question about? What is the row? Is it the one with an x at the beginning, a 2x squared, an x squared? What is the
with minus x squared?
The one with minus. Let's see. Oh, here we go. Okay, I'm going to assume you mean this row here. Okay, yes. Watch this. There's a 2x squared on this side, and there's an x squared on that side. Now, what happens when this x squared comes across? Younger, can you see that that becomes a negative x squared?
Yes, I see that.
Perfect. Now, can you also see that there's an x over here and a 2x over here, and together they would give me my 3x?
Yes.
Okay, so that's what I'm doing. And then essentially we have the minus 1 on this side and then a minus 1 on this side. But when that comes across, it becomes minus 1 plus 1.
Okay, then we equalize it to 0. Then we do the standard factorizing.
Yeah.
Okay, thank you.
So in row 6, how did you get x squared? So, oh, you're quite right. So I got 2x squared. This should be 2x. Yes, thank you. So it doesn't actually change the answer. What we have here, oh wait, no, I lie, sorry. How did I get it? What is 2x squared minus 1x squared? So if you think about that, guys, what is 2 of something minus 1 of something? It's just going to be 1 of something. That's it. Elspeth, I'll let you ask your question. Yeah.
So for the last question where you have x is equals to 0 or x is equals to minus 3, I'm a little bit confused because I understand how you got x is equals to minus 3, but how did you get x is equals to 0? Because wouldn't that be disregarding the other x? Yeah.
Okay. So this has got to do with quadratic equations. And if you think about it, Elspeth, if x was 0, basically there's two parts to this equation and we split them. And what we say is if this first part was equal to 0, that would be one answer. If the second part here, x plus 3, was equal to 0, that would be another answer. So it's basically just a step that we do when we're solving quadratic equations, in that we take the two parts and we make both of them equal to 0. And the way to see that x equals 0 as an answer is to ask yourself this: if x was 0, would it matter what the other bracket was? Because anything times 0 would be 0. I'm getting a little bit like, it's a bit strange and abstract, but basically there's always going to be two answers for a quadratic equation. The way we get them is by splitting after we factorized. Does that help a little bit, Elspeth?
Yes, so it helps a lot. Thank you.
Okay, cool. All right, then we're going to do one more question from this section, and then we are going to take a little break. Give me a thumbs up if you feel that was a tough question, right? So that was a tough question, but I wanted to do it with you. Give me a thumbs up if you're feeling okay, a thumbs down if you're feeling a bit, yeah. All right. So what I'm going to do, guys, I'm going to clear my board. But while I clear my board, I want everyone to try and solve 1.4. So I want you to start on this question. Fantastic, Cameron. That's the thing with maths. You just have to keep practicing and trying. And it's really cool that your questions are coming through now. So I really appreciate your questions coming through. Okay, so everyone, while I clean my board like a good teacher, I feel like I'm back in the days of chalk. I want everyone to work on question 1.4. I'll give you one hint. 1.4 is what's called an inequality. And so when you solve for an inequality, you're not just solving for two answers, you're solving for a range of answers. Okay, so over to you guys. And then we'll get some hints from the crowd after that. My hint is to factorize this because it's 4 marks, but if you factorize it, you've probably got 1 mark in the bag. So why don't you start with trying to factorize that? Lebo, is there anything I need to be aware of from the chat or anything?
Not at the moment, Mr. Ace.
Okay, fantastic. Aha. Okay, so now the question has been asked in the chat. Once we get to this step over here, what methods do we use to actually get the final answer? Because in this case, we're looking for values. We're looking for x values that if we put them in here, they cause this expression to be greater than 0. So what I'm going to do, guys, is I'm going to teach you what's called the sign table method. And in order to do the sign table method, you have to figure out the values, basically pretend it's an equation and ask yourself, what is the answer to this if it was an equation? And I think that following on from the last question, I said that in order to solve, if it was an equation, we would split this into 2 parts. And okay, Nolwazi, hang in there. I'm coming. We're going to sort this out. I promise. So I want to suggest that the 1, 0 value is going to be 8/7. And I want to suggest that the other 0 value is going to be -1. Now, I'll explain what that means in a moment. I do want all of us to observe this is not an equation. This is an inequality. And I'm looking for the values of x that make this statement greater than or equal to 0. But we need to follow a method for this. So I'm finding my 0 values. And what I'm going to do next is I'm going to put these 0 values on the number line. Now, there's going to be 1 0 value that's here, and there's going to be 1 0 value that's here. I would like you in the chat to tell me, I'll call this one A and I'll call this one B. I'm taking these, what I'm calling 0 values, and I'm putting them on this number line. Tell me in the chat, tell me which one is A and tell me which one is B. I just want to check your skills on plotting something on the number line. Yes, yes. Guys, you're doing well. So because it's a number line, this must be -1. And this one must be 8/7. Okay. Now, what I do is I call these values the 0 values because literally, if I put a okay, so one of my 0 values is -1. If I put -1 into this expression, so 1.4 expression was factorized into this. It's the same expression. If I put -1, it's the easiest one to see, into this thing, it makes the bracket 0 and it makes the whole expression equal to 0. So basically, these are called 0 values because the expression is worth nothing at them. In order to figure out where this is positive or negative, I choose a value bigger than my biggest 0 value. So I need someone in the chat to tell me what is a number bigger than 8/7. Give me a nice round number. Choose a number. Okay, 2, right? 2, fantastic. If I put 2 into this expression up here, is this expression going to be positive or negative? So I'm using 2. 2 is the number. It's bigger than my biggest 0 value. And I want you to put it into this expression 7x minus 8, x plus 1. I want to know, do I end up positive or do I end up negative if I put the 2 in? Okay, let's have a look. So 7 times 2 is 14 minus 8, that's a positive, and that's a positive, which means we end up positive over here. Okay, it doesn't matter what the actual amount is, Abigail. All we want to know, this is called a sign table, and it tells us whether the expression is positive or negative. Now, whenever I cross a 0 value, except for one special case, the value of the expression is going to change. So if I started positive and I'm going here, this is going to be negative. And if I go here, again, it's going to be positive. So what that's saying is it's saying, look, if I choose a number between -1 and 8/7, this expression will be negative. If I choose a number less than -1, it will be positive. So let's just check that. Let's choose a number less than -1. Can you guys put, let's say -2. If you put -2 into this expression over here, do you end up with a positive or a negative? Just for interest's sake. Can you check that for me? Okay, so what I think will happen, well, let me give you a moment. We can do another example after this one, yes. Okay, so be careful, it's actually going to be positive. So if you imagine putting -2, 7 times -2 minus 8 is the one bracket, and the other bracket is -2 plus 1. Now, this one is definitely going to be negative, because and this one, what's -2 plus 1? It's negative. And what's a negative times a negative? It's a positive. Okay, I don't want to go too much down that rabbit hole, guys. The main thing I want you to focus on is that it's changing as it crosses the 0 values. Okay, the final answer. Okay, the final answer is I'm looking for when it's greater than or equal to 0. Now, it's equal to 0 at 8/7, and it's also going to be positive to the right of that. So I'm getting to my final answer now. The other thing is it's going to be 0 at -1 and to the left of that. So my answer for this inequality is x is less than or equal to -1, or x is greater than or equal to 8/7. Okay, Pabalo, I think this would have confused you because you haven't seen this method before. And what I'm going to say is it's fine if you feel confused today. What you need to do is do another inequality fairly soon, and maybe I can even come up with one today for you. But I want to focus on the key steps before we have our little break. When I saw my inequality, the first mark was for factorizing. Then the second mark was actually for just ignoring it was an inequality and just treating it like it was an equation. So I just ignored it. And I just said, I'm going to solve it like an equation. When I solved my equation, I got what I call the 0 values, the values that make this equation 0 or this expression 0. The new step for you guys was putting the 0 values on the number line, then choosing a number bigger than the biggest 0 value, getting if it's positive or negative, and then letting those signs alternate as I went across the number line. And then ultimately, so that was one step, and then reading off the answer, knowing where was this expression positive? Well, it was positive over here and over here. Since I'm looking for numbers that are greater than 0, I'm looking for where is it positive or where it's 0. But if you're feeling unsure about that, you're not in a bad space. Just hang in there for now. Okay, I want to just take some questions and then we must have a break. Kakleko, go ahead and ask your question.
Hi, sir.
Hi.
So you told us that we get a mark for solving it like it's an equation, right? So what I did was I used the quadratic formula and then I got my x values, but instead of saying x equals to or, I immediately wrote my answer.
Okay.
So I would have lost the mark there.
Yeah, so normally we like to have a sign table step. So did you just basically get a mark here, here, and then there? And then you left that bit out. You would have got 3 out of 4, yes. Oh, okay. No, Wazi, don't. I hope you can stay with us maybe on mobile. Okay, but what I'm going to do, guys, yes, you can watch it later. And also, this was just meant to be a warm-up for inequalities. I think you can go back and practice another one. But I'm not going to do, for now, I'm going to rather prioritize seeing a little bit of everything today and just say, look, please go back and practice. Elspeth, go ahead and ask your question.
Sir, for the factorizing part, I did it a little bit different, but I ended up with the same answer. So what I did was I got 7x bracket x minus 1, but then I ended up with the same answer. And what I did was, I don't know if you remember, sir, when there was that previous question with the equation that I asked you a question about, and you said that x is equals to 0. Yeah, I got that. So I got x minus 1 is equals to 8/7x. And then what I did was, since I just made x equal to 8/7, and then x is equals to 1.
Okay, so you made a mistake with the 1. Have a look at the memo. I'm going to say for now, have a look at the memo, because I think if you see it there, it'll be easy to pick up your mistake. You're aware of your mistake. And so just have a look at the memo and we'll go from there. Okay, so guys, what we're going to do, we're going to lose some of you, unfortunately, load shedding soon. And I want to encourage you to watch the recording, but I don't want to rob you of a brain break opportunity. So I've found something a little bit different for a brain break. And so I want you to stand up from your desks, because we've been going for quite a while now. Stand up for a moment. have a look at the brain break and see if your brain can figure it out. Okay, but you need to be standing. I'm also going to be standing for a second, just so that we all get some blood into our kind of, I don't know, just so we get some oxygen to all the important parts of our body. And while we have that break, you can ponder what fish and jelly beans have in common. These are important questions, Lebo. They need to be solved.
Well, I'm just going blank at this time.
So I'm going to give you a hint. The watermelon may be your friend. Okay, so yes, the watermelon has a value of 1 in life. If it is a watermelon as I see it. Now, can that unlock some more stuff for us? Apologies, my camera is no longer in the right place. Aha. So I don't know if I have fish as 10. I have fish as 10 together, but each fish would need to be 5. Yeah, 5. This is definitely an upper class, problem. I went to find something special for you guys. So what do we have left to solve? We know that the lollipop is 25. Now, obviously, as you know, we're after this bottom one. I'll make this a little bit clearer. 25, which for me, that's 1, that's that. A jelly bean, 2 jelly beans together is going to have to be 15. And so what is the final answer, guys? What is the final answer?
2.
Ah, people are on form. They are 10. So well done. 10 is the correct answer. Okay, I want you to make sure everybody has had a little stretch because we're about to start the second part of the lesson. And I know you guys are powering through, and I just want to say well done. I know that this is, especially like these, I've actually done 2 quite tough questions with you. So let's start. I want to go straight to what I call this like the money maker question. So I want to see, do you know how to solve? Now forget about 1.3. I want you to try and solve that question. And there is guaranteed to be a 7-mark question in your exam around simultaneous equations. However, this is going to test a couple of skills. And so I'm going to give you 2 or 3 minutes to get going. And I'll give you a few hints along the way, but I want you to see how far you can get. Can I make it bigger? How about that?
Yes, that's perfect.
Perfect. Awesome. Lebo, do you remember doing simultaneous equations in grade 11? It's like it was the staple of the year. And your matric exam is guaranteed to have a simultaneous equation. Your June grade 11 is going to have a simultaneous, and it's glorious marks if you've got it down. Yeah. So let's make sure we feel comfortable with that.
Mr. S?
Yeah.
Asa has a question about the inequality sum we just did now.
Yeah, that's fine. I can do that.
They are allowed to use calculator to find where it will be negative and positive, correct?
Yes, you are. You are. So what you could do is you could say, find a value between, I think it was -1 and 7/8. So let's say 0. Put 0 into the expression, see if that expression is positive or negative. Then you've got your value for the sign table. And the main thing to remember is that as you cross over the zero values, the expression will change its sign. It will go from positive to negative, unless there's a double root, which is a special case. But most of the time, it just changes every time it goes across a zero value. So my little hint for you, and this comes from doing simultaneous equations in many places, is always try and name the equations, sort of equation 1 and 2, and think about which of the ones is easier and which of the ones is harder. And my suggestion is you sub the easy one into the hard one. Okay, that's my little tip. And so I'm even going to go so far as to write equation 1 in that sense. Okay, so how do we sub in? Well, first of all, we have to decide what we're subbing in. Now, because of my choice over here, you'll notice that I wrote my equation in where one variable is the subject of the formula. Now, I chose y because I just thought y seems easier. If I'm going to sub it into the other equation, I like to give it a home to go to. And so the home it's going to go to is y. And so I leave it blank and I write the equation out, the other equation out, and I leave a home for y because I'm substituting y into that home. Does that help a little bit, Cameron? Okay, and I want to see if from my hints from there, if you guys can take it. So step 1 was to identify the easy one, then to choose a variable to be by itself. And now that equation needs to be substituted into a home in the other equation. Okay, Ezra, we are changing that today. I'm going to give you a recipe for success. I promise you. Whenever you have a simultaneous equation, all I want you to do is to look for the simple one and the harder one. Then I want you to work with the simple one. We all like working with simple things, the delight of life. So work with the simple one. But sometimes even simple things need a little bit of shaping. So we've rearranged x plus y is 4 to y equals 4 minus x. Okay, but now comes the important step, the substitution, where something simple needs to go into something more complicated. And this eliminates one of the variables. And so I like this idea of making a space for something before it arrives. It helps my brain remember what I'm doing. And so I want to suggest that if you can get to that step, you're well on your way to success here. Okay, now, would anybody like to tell me what the sneaky bit is that's coming up next? No, Wazi. Okay. The biggest thing now is this blimmin' bracket, right? So I have to deal with this 4 minus x squared. Now, some of you will know a shortcut, okay? Some of you, I would suggest it might be better to write it out in full. I don't know what methods you guys prefer. If you do it the slightly longer way, you should get something like that. And now I need to bring these worlds together. So what I'm going to do is I'm going to say, well, those two together give me 2x squared. Minus 4x gives me minus 8x. Now, how do we handle this? These are on opposite sides. So I think when these, I think I'm going to bring the 40 across. And if I bring the 40 across, I'm going to get plus 16 minus 40. Okay, now that can be simplified further because I can get a final thing of 2x squared minus 8x. And then what is 16 minus 40? Don't be afraid to use your calculators if you need to, especially if you're feeling tired. Sometimes we make silly mistakes. Okay, so I'm just going to pause for a second because I don't want to go too fast. I had to multiply out my brackets, and now I do what's called collecting like terms. At this point, some of you will decide to use the quadratic formula. Some of you will choose to divide by 2, divide everything by 2. If you do that, you will get that equation. Some of you will, there's many ways to do this. I am going to use this, let's just make sure I've got, okay, so I'm going a little bit quicker, but I'm factorizing, and you should get an answer. Let me just make sure that I am. You should get an answer of 6. In fact, let me even show you how I split this. So x minus 6 is 0. X plus 2 is 0. And then x is 6, or x is minus 2. Now, if you use the formula here, you should have got the same answer. However, let's pause for a second and get some questions. I know some students are struggling here. Would you like to raise your hand and we can have a quick little chat about it and see where we lost you on the journey? Okay, so Teddy, I'm going to ask you to just ask a question here. I think I'm unmuting you. Yeah. Yeah.
Is it fine if you make x the subject? Because I said x equals to 4 minus y, and then I substituted.
You could, yes, no problem at all. You'll still get the final answer. But now, Teddy, can I ask you, I've got my answers for x. How do you think I'm going to get my, I need to still get answers for y. Can you give me a hint? Because I need to solve for both x and y. Would you be able to help me, Teddy? How do you think I get my y?
I'm not sure, sir.
Okay, can you see the green bit up here? We said
yes,
y
sir.
was equal to 4 minus x. Could you use that to give me a y? Like how do you think I use my x answers to get the y value? Okay, but if you don't know, that's fine. I can also, not a problem. Seth, I see your hand is up.
Sir,
I'm gonna,
can you hear me?
Go ahead, Seth. Yeah.
So does it matter if I used x equals 4 minus y instead of y equals 4 minus x?
It doesn't matter. No, doesn't matter. So as long as you get the same answers as me, and let's just check we get the same answers. So I've said y is equal to 4 minus x. So I have 2 possible values for my x. And so what are those 2 possible values? The one is 6. The other one was minus 2. And so what I should now get is y is minus 2 or y is 6. And so those are my final answers for those 2. Okay, can I go through the steps from the beginning? Let's go. Let me just quickly run you through the steps so that it becomes familiar. Step 1, and you actually get a mark for this, is to choose the easier one and to isolate a variable. In this case, I isolated y, but lots of people would suggest that if you chose to make x a subject of the formula, completely fine. Okay, so that was the one step. The second step was to sub into the more difficult equation, which is this one over here. Then I had to neaten up my life and I had to multiply out and collect like terms. And that got me all the way down to here. And then I did some more cleaning up and I got to this part of the world. And eventually I actually factorized and solved for x. Then the final step was to get y. I had to take these x's and put them into the formula where it's y equal to something. And that's what I'm doing at the very bottom here. So again, guys, thank you, Taylor. Yep, that's exactly it. Bongo, you have a question. Then we're going to move on after that. Yeah. Go ahead, Bongo.
My question is, why are we dividing the equation by 2?
Okay. All right. The reason I divided by 2 was I wanted to make the equation simpler. Say that again.
X squared minus. Oh, shit.
Right. So what I did
my computer just died.
Okay. So what I just did was yeah.
Because of load shedding.
Okay, shame, man. I'm sorry to hear that. All I did was I divided by 2 because it made the equation simpler. But for those who used the quadratic formula at this point, you would have also got the same answer as me, which should have been x is 6 and x is minus 2. I agree, Taylor. I think it is easier to factorize. It depends on where you are on your journey. If you're good at factorizing, I would say factorizing is easier. If you're uncertain of factorizing, use the formula. Okay. That's my hint for you. Now, I know we're not perfect, but we are going to move on just so we get to experience some other types of questions from typically paper 1. And so I'm just going to move up to this question over here. And we call these 2 questions simplification questions. And I want you to try and simplify. Let's just do 1.2.1 first, and then we'll move on to 1.2.2. So simplify without the use of a calculator the following expression. This is from the exponents and surds section. If you can't see clearly, this is 125 to the power of 2/3. Can you simplify that for me without a calculator? I'll give you a minute or so to try, and then I will assist. Okay, Muzi, I see your hand is up there. Go ahead.
Yeah, so I did 125 over 2 over 3, right? Is equals to 3 at the front, like the I did basically.
What was the key step that you used? What was the very important step that you recognized?
Now I did square root 125 squared, and then I put the exponent 3 at the front.
Aha, so you split it into or did you? Okay, I see what you mean. So I think what you're saying is you said that like that.
No brackets, just
No
put
bracket,
the squared next to 125.
Can I suggest, Music, because it sounds like you've got the right answer, but I was thinking probably the quickest way to do this is to recognize the 125 is the same as 5 cubed. Did you see that early on in the question?
Yeah.
You did recognize that?
Yeah.
Perfect. So now what's going to happen is that was your final answer, because now you get to multiply these two.
My final answer was 25.
Yep, which is exactly what I get.
Yeah.
Okay, so all I want to point out to everyone here, and so Muzi's actually done it a different way and got the same answer as me. You obviously understand this type of thing. A really important skill that you need to use in exponent questions is to always break down big numbers into what's called their prime powers or their prime factors. And so the key step in this question was just to recognize that 125 is 5 cubed, and then to apply the power law where you multiply the exponents together. So I see Jermaine got the same answer. Did anybody else get 25, or did anybody else struggle with that question? I just thought it's good to go back, and there's always an easy question, or there's always a question like this in this first question of the exam. Okay, fantastic. All right, let's have you try the next one. This is what's called a surd expression, and students sometimes find them a little intimidating. So let's just see that you can do those. And then once you've got the answer, pop it in the chat. So a useful tip with this one is to think of multiplying out. Can you carry out the multiplying out? If you can, I think you'll be in the right part of the world for this question. Okay, so remember with this question, guys, you're not allowed to use your calculator. So you have to multiply out. And I would love for someone to tell me what, oh, the motorbike is driving past. This is what often I find gets students. So can anybody tell me what is square root 2 times square root 2? It's a bit of a strange one. Yeah, it's 2. Exactly. And so this whole thing is actually 12, or maybe I should write this above here. So 6 times 2, this thing is going to be 12. We have a, so I should put a little bracket here. This whole thing is 12. Now there's a minus 12 down here. So what happens is that these knock each other out. Now remember, you're not allowed to use a calculator. So what have you got left? You've got 3 root 2s minus 24 root 2s. And so then the final answer is going to be what? It's going to be something root 2. Oh, I see Kaklejo has already got it. So it's going to be minus. So what is 3 minus 24 is maybe the way to think about it. Well, 3 minus 24 is minus 21. But we don't have any normal things. We actually have minus 21 root 2. So did you use FOIL? I did. I did. So basically, if we go back to the beginning of this question, I was just multiplying each term by every other term. So the very first bit was that one. Then it was that one. So that was the first bit. And then I did that bit. And then I did that bit. And that's how I got my 4 values. It turned out that the front value was 12. And so those knocked each other out, which meant I could just concentrate on these 2. Okay, can I explain the multiplication of surds? I can. Surds are a bit weird in that if you've got, for example, here, the square root of 6 times, these are both square roots. That gives you the square root of 12. So as long as it's the same sign, you can just multiply what's inside. If, however, for example, if I said square root 2 times square root 8, I'm interested to know, do you guys know what the answer to square root 2 times square root 8 is? because this is, I've seen this many times. Surds are confusing for students. I'm hoping I can do a little bit of recapping with you now. So what is square root 2 times square root 8? Using the idea from above, it's square root 16, which is actually the same as 4. Okay, so what we have to do with surds is we just need to make sure that they're both square roots. If the one was a square root and the other one was a cube root, you can't do it. But as long as you've got the same type of surd bracket, you simply just, if you're multiplying in front, you can just multiply the numbers inside. And so that's what happened in this question. Like when we went root 2 times root 2, we actually got square root 4, which was actually just 2. All right, let us try. I'm gonna, give me a thumbs up if you sort of get that. Give me a thumbs down if you're feeling very confused, because I'm gonna remove some of this working so that the screen is a little bit less cluttered, but some of you may be still writing stuff down. Okay, Kozi, we'll hang in there. That is, I'm just giving you a taste of surds. So some of you maybe just need that awareness to go, oh, I need to practice a bit more surds for the exam. The main idea that I find helps students is to just know, like, the way that surds can just be split like this. Like the square root 7 times square root 3 is square root 21. Okay, so Ezra, you're feeling a little bit confused. Can I suggest that you just have a look at a couple of other surd questions? I think that your confusion is at the beginning of your learning journey. And so, even if it's too much for you today, then just ignore surds for now. And when you're ready, you can keep going with that. Bukhlale. Yes.
So can you explain 1.2.2 for the last time?
1.2.2. Bukhlale, I'm rather going to ask you to look at the recording of this and go on to another question. I think that it will be a better use of our time for now, but I thank you for your question. I'm just going to say rather refer to the recording where you can get the repetition of that. Okay, what I want to do is this will be our second last question. Can you do one? This is a expression, and the first part is, do you know for which values of x will this expression be undefined? Now, I'll give you one hint. Things are undefined when x is equal to 0, or when you have division by 0. So think about, in this expression, what would cause division by 0? And then see if that can help you. I'll give you one other hint. I'm going to factorize the denominator. And so I want to know, does that help you see what would cause division by 0? Well, I think that this will be 0 when x is 3. So basically, if that x was 3, what you're going to have is that, and then eventually you're going to have 0. So for which values of x? When x is equal to 3. Okay, now the second part of the question, simplify the expression fully. This is going to require you to look at the whole thing and think, okay, how do I have these top and bottom bits interact? What can I do? In order to simplify this expression further, what technique do you almost always use? You could use common factor, Cameron. On the bottom, what do you have to use for the top? It's a special type of algebraic expression, I think. This looks to me like a trinomial, doesn't it? X squared minus x minus 6. If only we had a way of factorizing the green bit. Why don't we try that that method? Yeah, Muzi, I see your hand is up. Yeah.
Okay, look, I don't know if this is correct, but
it's fine. Give it a go.
I did x squared minus x minus 6 times 3x minus 9.
Okay.
And then x squared minus x minus 18x minus 9.
Okay.
And then I got x squared minus 19x minus 9. That's my final answer.
So what I think may have happened is you may have added some extra stuff to the question. But thank you for your answer, Mizzy. What I'm going to do is I'm going to show you what we could do. Is we are going to factorize this top bit. And in order to factorize the top bit, you are going to get, so we're going to get x minus 3, x plus 2. I'll just check that that does work out. It does. And so now, if we do that, I wouldn't have, I think maybe you multiplied the top and bottom by something, which I think it wouldn't have helped you to simplify straight away. But if you factorize the top and bottom, what do you notice about the top and bottom in this case? Do they have something in common? Or do they have something that's there? Yes, the x minus 3. Now, what do you think we're going to do with that x minus 3? Okay, I think that this is going to be the same. Let me just 2x minus 6. I think that x minus 3 over x minus 3 is the same as 1. And then what we're going to find is that the final answer is just what's left on top divided by what's left on bottom. So x plus 2 divided by 3. Okay. So this is an example of where you have to factorize to kind of get into the question. Okay, guys, what I'm going to do is we're going to finish with one more question from something called the nature of the roots section. And there's more questions that you can practice later. However, when we are generally working with nature of the roots questions, we always need to find something called delta b squared, well done, b squared, which is b squared minus 4ac. In order to answer this question, state the nature of the roots. Now, there's a way you can do it without doing this, but I'm going to do it for today because I think it's good practice. Can you guys find me delta for this particular equation? Now, it may require a bit of working, but see if you can find delta. And then we're going to finish today with just classifying the nature of the roots for this particular question. And maybe I'll squeeze in 2.2, and that will be the finish for today. Okay, so just to remind you, we're trying to find what delta is for this equation. And then what we're going to do is we're going to state the nature of the roots based on what we find for delta. Over to you guys. I think our friend, Mbali. Okay, so I will show you in these last 3 minutes. Let's start by pointing everyone in the right direction. If I multiply out this question, are you all okay with getting that? What do we have? We have these. So we get, okay. All right, fantastic. Now, in order to get delta, we need to have it in standard form, and we need to know what A, B, and C is. So can you put in the chat, what is the A value, or what is the A value for this question? What is the B value? What is the C value? I think the A value is 1. The B value is -3. the C value is what? Okay, it's not just 18, it's minus 18. All right, so if I want to find delta, I can now say b squared, whatever that is, and then I need to sub in my values. Now we know that as long as I haven't made a silly mistake, yeah, minus 3x, that's fine. We have minus 3 there, we have 1 there, and then we have minus 18 here. What is my delta value going to be? Now remember, delta is this little thing inside the quadratic formula. Okay, so I see some answers coming in. So I get 81. Yes. Okay. So delta is 81. Now, once we have worked out what delta is, we can state the nature of the roots in terms of the delta gives us information. Now, if delta is greater than 0, then the roots are unequal. So are my roots of this equation unequal based on my delta value? Okay. It looks to me like, okay, Cameron, I would disagree. I think delta is greater than 0, and so they would be unequal. Yeah, okay. Is delta, or basically, yeah, is delta a perfect square? If you look at 81, is delta a perfect square? Yes. Okay. So what does that mean? It just basically means that the roots are going to be rational. Okay. So as long as that, as long as delta is a perfect square, the roots are going to be rational. And then the last one, so unequal and rational. That was actually only 2 marks. So we probably need to state 2 things. Otherwise, we can also say that if delta is greater than 0, the roots would be real, but I don't think that would be needed in this case. Okay, so all I wanted to finish with today is if you have a nature of the roots question, you're almost always going to have to find delta. If you find delta, there are certain properties for delta that tell us about the roots of the equation. And so what you're going to need to do now is go back and learn, okay, well, if delta is equal to, for example, I said, if delta is equal to 0, then the roots are going to be unequal. Sorry, the roots are going to be equal. And so I'm not going to actually go into that too much detail, but basically I want you to just go back, think about working out delta, and then thinking about what facts you need to know about delta to know the nature of the roots. Okay, guys, it's now past. I hope that today, I know we try to cover quite a lot of stuff. I'm not going to do completing the square right now. What I'm going to suggest is that you go to other videos we've done. But I am going to ask you now we're going to pause the session. But what I'd like to do before you go is I just want to get a sense of the pace for you today as a student. Did you feel like, how did you feel about the pace? And it just helps us plan our sessions going forward. And so we're going to finish with that. And I really, really hope that you had a, well done for working so hard today. It really takes a lot of effort on your part to come out for these things. Buklalia, I'm so happy that you feel like you understand nature of the roots a little bit better, because you have been asking about it for a long time. Yes.